Alright, hello everybody. Hello from Romania, from your favorite artist electronics here, Mr. Q12. What I did here is having multiple names, and this is a part of the circuit. This is not the entire circuit, but every module, vertical module that I have here, is repeating. For doesn't matter what value, is the same configuration. The same circuit diagram if you want, but only the values are changed. So for 100k, I have every one of 100k, 1 mega, 1 mega. Okay, in my case, so it doesn't matter what it says here. This is only for reference, only to know what I have to do. And I built this prototype, if you want. Why I'm calling it prototype? It's definitely not something new. I actually took this circuit from internet. I tried to make it in a Proteus simulator by myself, but I got very quickly quite complicated. Building it by myself, trying to figure it out. So I said to myself, the smart way is to look for a circuit that is already made on the internet, and it was a good idea because it was. I did find it, and this is it. Very well planned, very well put together, very smart, actually, very, very smart. I really like it. I couldn't find some solutions by myself and quick enough. So I cut some time by finding it, definitely. And this is the module that I made it exclusively on cardboard. It's this cardboard that you can see here, you see? This is the cardboard that I use. It's a very good cardboard. It's very thin and very strong, especially for this size. This size is not that big. When it's bigger, it's more flimsier, as a cardboard is. But for this size, it's absolutely perfect. And so what I did, I built this module that you see here, the white one, from, let me point. So from here to here, and I put some resistors there. 1 kilo, exactly as you can see here, and a very thin wire that you cannot see, but it's very, very thin. And I had some problems diagonally like this, and everything is working as it should be. So it is a success. Why I'm saying it's a prototype, because I never built something like this in my life, and it is posing some challenges. One of the challenge is this part here that you can catch with your finger, with something, with your skin. If it's a little bit of skin peeled off, you can catch that very fragile wire that is there, and you can grab it and take it out, and it's fucked up, and you must have a little bit of protection, or at least I must have to have that protection here. So I put another cardboard and I glue it on this side here, and it's only bent there. Let me try to actually unbend it to actually show you those wires, if I will not fuck it up. Good enough. So all right, so voila, it is cardboard after all. And let me zoom into it. Let me put this paper. So right now, let me zoom in, and you see those very, very fine wires that are diagonally everywhere on each resistor there. You see, that's how it's made. And I had some very, very technical problems to resolve, and that's why I'm saying it is a prototype, because I had to do some new, a little bit out of the ordinary, that a little bit different from how I'm doing it usually. That's the thing. So I had to calculate. This was the plan on the paper first. The first thing I did the plan. This is the first idea, how to put everything. This is the common line here that we have it hashed here, you see, and it is this line. This is common for every pin. So every pin is bent and stick on the soldered to that common band that I have there. Okay, and and then I realized when I made this first one, I realized the space between these jumpers pins is too great, it's too big here. What I did, I used this and I cut it 2 by 2. I cut it from here and I leave only 2 of them, you know, and after that I cut another 2 and I leave only 2 of them, and so on. This is how I build this module that you are seeing here. And as you can see, they are a bit wavy. They are waving a little bit. They are not perfectly fit, but they are good enough. They are good enough, especially made at home. And then this is the second take. I did look on the commercial version, and the commercial version is having them all exactly in this configuration that I'm having it right now, all close together, back to back. And I measured everything with my caliper, and this is 2.5 millimeter. The thickness of this black plastic that you see here actually is the thickness of that, and this a little bit smaller pad is 2 millimeter. You see, and it's the pad here, and the one leg of the jumper module is bent like this and is soldered there, and the other is bent like this and is soldered here, and this is a little bit longer. So I don't know, here you see the wide. So from here to here, pretty much to almost to the end, is letting a tiny bit of space, enough to put the one leg of the resistor. And this is the resistor here. You can see it here as well, the actual values, the actual dimensions that I measured directly on the resistor itself. And it's long 3.3 millimeter and wide 1.5. And this is here, and is stepping a little bit here on the pad. Okay, so this is long enough for the leg of the jumper there, but not entirely, until somewhere there. And then the one side of the resistor is catched here until there on the other side, and this side is floating, is actually staying in the air. The resistor is not parallel, is not staying parallel, is bent like this a little bit, so it's having 2 points of up here and down here on the board. why do I say it's unusually from my way of doing things is because uh, I had to calculate, and usually I don't calculate this strictly, this precise when I'm building. It's a very light calculation, but not this strict. And I had to be careful on this 1 millimeter distance between the pads, not to make short between them. This dimension, exactly this 2 millimeter dimension that I have there. Also, this 2.5 millimeter distance from here to here, and also be careful. I was very, very careful to leave this distance between the pads, and I measured every time when I cut the piece of the pad itself. I measured every time. I compare it with what I'm having here on the paper. The pad itself is a little bit longer, as you can see here. It's 4 millimeter wide here, but in total it's 7 millimeter to have the ears to bend them underneath. And I cannot show you that because on the other side, because it's already glued. Because I should have filmed, but I didn't. It's not really a big mystery. It's having on the other side. It's showing all the ears that are bent underneath. So they are bent like this. And here are the total length of the thing. I had to put to sync on the number as well, to include it as well. So the width it got a little bit more wider than I wanted to be. And this pad is a special pad, is the good pads that I have, not this shit material that I'm having. This is shit. Very, very expendable. In the things that I'm doing here, at least. I believe this is from can sprays. This kind of metallic strap. You see, it's golden and it's shiny there. This is from a bottle, a can bottle for spray, and it's quite thick, quite durable, and quite bendable. That's the point of it. And also the solder adheres to it very, very well. And there is a problem with all of them actually, not only this. If I'm holding the heat too much, I don't know how much, like 20 seconds, 30 seconds, I'm not exactly sure. It's not a exact science, but if I'm holding it way too much, lingering on the surface, so it's 300 degrees or something, the substrate, it's like a film, that is deposited on the metal, on the iron, or the steel, very mild steel, almost a composite of iron, and that is not catching anything. But this, whatever it is, I believe it's called chrome, probably, it's chromium, no, is deposited on that surface of iron or steel, mild steel, and this is like a very, very extremely, probably atomic, like a very fine layer. That fine layer, like it's like a page, is actually peeling off if I'm keeping the iron too much, excessively much, on the surface here, and around it, it will peel off. It will be destroyed pretty much. It will get out of adherence, and also the solder along with it. So the solder will not catch anymore on the metallic, on the iron based or the steel surface that is under this chrome preparation, that layer that is having there. So that's the biggest problem that I have. I have to be careful not to linger too much with the heat on it. For now, I had absolutely no such problem here, but I know the problems. I know from my past exercises, the past experiments that I did, and that's this particular one is a bit more stronger, and actually I can unbend it multiple times, not many times, but multiple times, from difference from this one, which if I'm bending it once and that's it. If I'm bending it out, if I want to take it out, it will snap from the bending, it will cut off, and this can support multiple bendings and unbendings, reshapings. So that's why I'm saying it's very, very good material to work with, and I'm having it here. I use that here as the pads. I use the best I have, the best cardboard, the best pads. Why I use the best and not the scrap ones? Because this is a big problem here. The jumpers, they have to sustain some force when I'm dragging the jumper out, and you can see it. I can show you 1 second. And this. You can see when I'm dragging it out. Right now I'm dragging it with some force, and it's not coming out like that. You see, and that force is exerted on those pads, on that pad and this longer one. But this is kind of reinforced by the other legs that are soldered, the left one here, and is longer and way more stable. But the right pads that I'm having here are quite fragile, and especially if I'm doing this too many times, I hope it will not get out from there. But if it will, I will be totally screwed. I'll have to find a way on connecting them, not so tight, something like this. You see how it's a bit hard to take it out, and it's dragging. And also I discovered that's why I put this black support here. That's why I glued. This is the glue that I used. It's a Romanian adhesive, Prenandez. It had along the time. It had many names, but this is not the correct name. It is Prelandez, but probably it differed in time. Doesn't matter. This is for gluing shoes, walking shoes, and it's quite strong and very, very, very good adhesive. It's like rubber, very hard rubber when it's cured, and it's not like a cement. It's rubbery, but very hard rubber, and is catching extremely well. Quite a lot of very different materials, even the shiny materials. I don't have to scratch them. It's very good. I'm using it all my life. I know it all my life. and that's I glue it. I glue this this module that you see here on this longer black cardboard. Why? Because in the moment I was dragging the jumper from here, this frontal part here, and also on the other side, on the back here, was bending up because it's very fragile here in the start. And then I've noticed that very quickly, quite quickly. So you see, if I'm dragging it right now, it's a little bit, it's trying to bend everything in this direction, and it is probably a little bit bent like that. But that's the problem that I'm dealing with right now, and I hope that's why I'm saying it is a prototype for me. It is a prototype to test all the materials and all the forces that I'm applying here, and so far so good. Let me show you how everything is behaving, if it's working or not. I have here the multimeter, and it's set to 20 kilo, and I'm putting here, doesn't matter the polarity here. This is 9, 8.9, it means 9 kilo, and you see it's set to 20 kilo, so it's 9 kilo, 8 kilo, this is 7, 6, 5, 4, 3, 2, and 1, and this is 0. But on the last pin here is 0. Actually, I did it inverse. You use it the other way around. You move the jumper and you take the measurements from here and here, not per each. But this is a test that I did. I can demonstrate that very quickly. So right now, if I'm taking the value from here, and here is 0 because the jumper is on the top. But if I'm moving it, let's say here in the 3 mark, it should be 3 kilo right now, if I'm catching it. Right. I have a strange angle. So it's set on 3 there. So the same pads, you see, 2.9. It means 3. So that's this is how you usually take the measurement. And I have another option here. So this is the circuit. I modified it very little from the original. The original was having a little bit of different wiring, very little different wiring. But my wiring is a little bit better. At least for me, it's better. It's more cleaner what I have here, and it's good to have a little bit of diversity of circuits, you know, to see how others are making it. And also I have this module here that this is brand new. I have a scrapped one with only 3. That's it, only 3, and it's rotary with a wheel that will spin. And I searched for those with rotary spinning wheels, and I couldn't find. I only find this module. And this, by comparison with that one that I have that is scrapped, is this big, long, and a little bit bigger than this, like that. And this is obviously is a bit smaller, not with much, but a little bit smaller. And smaller is better. Always is better smaller. Also, the pads are smaller, so I have to take care. If I'm building something like this with SMDs, with resistors, and I'm thinking with resistors somewhere there, I'm not really sure how I will make it, but I believe I will try one, at least one. They are extremely modular, very good, and probably 0. It will not be connected to anything because it is having a pad that is saying 0 there, and another pad that is the letter C from common. That is the common, and then it's starting 0, 1, 2, 3, 4, and then 5, 6, 7, 8, 9. So 0 will not be connected to the common. So 0 will be absolutely no connection, or some sort of connection probably, like here. Probably this is 0 here on the top. Also is marked as well. I will see how I will make all the connections between them. But for the moment, 0 will for only one module that I will test. 0 will not be connected to anything, and only 1 and 2 and the rest of the. And when I'm cycling like this, it will show the value, and it's pretty cool. And it's cycling back to the start. And it's very interesting idea that I had, and probably I will put it in practice. Probably. I'm not sure how many I will make of this because now I have 2 variants, 2 alternatives to make, either continuing like this or starting this one. And the best idea that I have, let me put it back if I can, if it will stay there. I hope it will. So the best idea that I have is to have them both, to build them both. So to continue this project as I started it, and I'm not sure if I will make. Usually the original circuit is having 7 modules, starting with 1 resistor, so 1 ohm, and for each you will get to 9 ohms. 1 ohm, 10 ohms times 10 ohms times 100 ohms times 1 kilo. So let me show you on the fingers. So 1 ohm, 10 ohm, 100 ohm, 1 kilo, 10 kilo, 100 kilo, and 1 mega. So it's in total 7. And I'm not sure if I will make all 7. I will make what I'm using the most. And because this is the beauty of cardboard or building on cardboard, you can cut or add other modules. If you are making it like I'm making it, modular enough, if you are thinking modular, like I'm presenting here, it is possible to add more modules or take out other modules that you don't use. But in this case, I will be able to add more like this, make them in time. So for now, I have the 1 kilo module. Next one, I will make the 10 kilo and probably the 100 kilo. I'm not sure. Or the 100 ohms. 100 ohms, 1 kilo, 10 kilo. Because these values, I'm using them the most. 10 kilo and 1 kilo, and sometimes the 100 ohms values that I'm in between. These 3 are the most used one in most of my projects, but not quite correct. I should make them full, all of them. I will see in time if I will be able to, because this was very hard. I worked on one module, this module that you are seeing here, one day, and I'm not totally perfectly sure if it is strong enough because of this pulling. This is the problem that I'm having. When I'm pulling it out, it is catched quite strongly there, especially in the margin here and here, and it's kind of delicate, you know. But right now, when it's brand new, it's quite strong. It's behaving okay, you know, very good. It's behaving, but I'm not sure in the long run how it will be. So I discussed this subject to death right here. I forget something. I calculated very quickly times 7 modules. I have 18 millimeters wide. This wide here. It will be 12.6 centimeters. Or 136 millimeters. So it will be like this long, 100, something like this big. All the 7, the entire board. If I will make all the 7 of them, it will start from here, probably 12 or 13, depends, because I've added a little bit more stuff there, and it will be like this big. It's acceptable probably, but I will have absolutely every value usable in electronics, and it's that's why I like this design. I really like it. This is for quick stuff that I'm most using it, you know. And I will have to make a case, a metallic one, most probably all around. That's the idea. That's the idea that I'm thinking, to protect whatever I have here, and 2 wires that came out, you know. And that's it. And I will connect those 2 wires, and then I will select from here. And that case will keep them falling apart as well, encase them like that, either from wood or from a sheet of metal. I don't know, probably metal, because it's thinner and stronger. And the same strengthness as wood. If the wood is like this thick, the metal it will be like this, but the same strength. So voila, this is it for now. I think I covered everything. Yes, what I'm demonstrating with this project, and I'm demonstrating it to everyone, but mostly to myself, that it is possible to make it even with cardboard. If you really want it, you can do it, even with cardboard. So this is the preparation of the cardboard. It's exactly the same size as this one, and you probably have to look it like this. Yeah, it's there. I will have to chop off some remains, but it's practically absolutely the same as that one. You see here as well. And this is a rest. I cut it off from that one, and I use it as a measure for this one as well. So what all these lines means, it means that here is what I hashed is the longer common bus, if you want. This space from here to here is the plastic that is holding the 2 pins, and one leg will be bent like this, and another leg will be bent like this. And from here to here, not to there, to here, it will be. This is the length of the pad itself, and this overlapping that I'm having here from here to there is the resistor. So it's a bit weird how I make it. It's a bit funny to understand it, but it is giving me a good plan what I have to do. So this is a sample resistor that I'm using. Let me actually put it perfectly on the line there, something like that. And you see, zoom in, and there it is. Of course, I leave a little bit of tolerance in this side, but everything else is very strict, very precise. Well, very. I kind of did this by eye, but the first one I did calculate the shit out of it, and I was extremely careful for everything. This one I make it by eye a little bit. I have some irregularities, very small irregularities, but I know they are. But it's not really a big problem, because I know that's why I'm calling this a prototype, because this was the leading. You know, if this was failing, I would not start another one. But since this is good enough, I can you know, start another one, and hopefully it will not be a waste of time, the entire project. I mean, we'll see later. Bye bye. Just a preview, just a quick look. I've already assembled quite some of them, and this is how it's looking from the other side. I cut a little bit from the ears that are bending there. I chopped off a tiny bit because the hole is quite small, and this width of the metallic of the pad is too wide, and is not fitting if I'm not cutting it. And pointing it like this is entering very quickly through that hole. That's the whole purpose of you don't have to do it, but here with these dimensions that I have very close together, it's a tiny bit of cardboard there between the pads, and that's what I'm very concerned with. And by pointing it like this, it's kind of making itself you know, fitting itself in the right dimensions, pretty much, you know. And here I prepared some holes. I'm doing them as usual with the needle here, and yeah, that's the preview. This long strip that I have here is actually a foil. It's a copper foil that I scrapped from somewhere. It was a bigger foil like that, and I'm cutting strands from it, and it's long enough, perfect long, as to have these ears here to bend them and reinforce them with solder there, and it's good enough. It's good enough. So that's the progress so far. I want you to see it. Small update: the board is finished. At least the pads, all the pads are finished. Look how shiny they are, all prepared with the solder and before hands. And this is the back of it, how it's looking. Very strong link linkage like this. It's catching extremely well. Quite some work. I'm not sure how many hours, but it took me some hours. And next I will have to put the components on there and make it resemble like that. Hopefully. With this one will be, I'm not sure, 10 kilo or 100 ohms range. We'll see. But for now, this is finished. Another update. Here I put the jumpers and the 10 kilo. These are having some very weird markings. This 10 kilo that I have, it says there, these are reboot, these are bad resistor markings, very bad. It says there 10, actually 100 and 2 zeros. So in total it is 10 kilo, so 10,000, you know. But it's very similar to 102, which is 10 and 00, 1000 ohms. So yeah, lucky me. For this project I will have a big label there on the top, pretty much like I'm having it here, that will say what range it is, and not actually look on the resistors values themselves, and actually put a cover over them to protect the wiring. That's the cover for that black cover that I'm having there. It's for the wires. Very thin, very fragile wiring, and it needs protection. Right now on this module I didn't put absolutely any wires yet. I've only put the jumpers here and the resistors, and that's it. No wirings. But I wanted to show you, to update you, to make this little update about the process and how things are made. All right. I started to wire, but I didn't finish it yet because I want to show you how I'm wiring it. Right now I'm having it until here. This is the last wire that I put from here. 1, 2. So it's the wire is this diagonally like this. 1, 2, 3, 4, and 5. And now this is unwired here to this. And I hope, let me actually zoom in to show you everything. You see? And that's 1, 2, 3, 4, 5 wires, and 6, 7, 8, 9 there. But I will show you only one if I can, because I don't have this kind of resolution that I'm zooming in from my phone right now. Actually, you know what? Yeah, I will have to get somewhere there in the center. Okay, this is maximum zoom I can do, and I have to keep that in place there, not moving it. I hope I can manage to show you. Actually, let me zoom out a tiny bit like that to show you how I'm preparing the wire. The wire is kind of prepared. It's very thin wire, as you can see. You can barely see it. And how I'm scratching it, preparing it. And let's see if I'm putting my finger here. Yeah, okay. Oh, somewhere there. So this is I'm scratching the isolation from the wire like this. I really have to scratch it only on one side, and it will be conductive enough. But I am thorough, and I am scratching it on multiple faces. even if this is a round wire, I'm imagining it as having faces that I'm scratching, pretty much. And let's see. I know it's weird how I'm explaining it, but doing it is what I'm trying to make you understand. All right. So let's say this wire is good enough. It's isolated, good enough. And okay, I will have to pay attention where the thing is, because I will be concentrated there. And somewhere here is the middle. Okay, let me actually mark it like that to know exactly what the hell. So this is the middle somewhere here. Okay, good. And to stay in this area, you know. And that's why it's good to have a paper here. So right now I will prepare the tip of the wire. This is exactly how I'm doing it all the time. And now I'm scratching a little bit the tip of the wire to be sure that the solder get into it. I'm not sure if you can see, but it is a distinction. The copper is red and the solder is a bit white in the tip, and that's what I want. And I will have to work from a distance. Usually I'm getting very close with my head to actually see what is going on there. These resistors are only catched in one place, only there is catch. Here is free, is floating. So I will have to deal with that solder that is already there somehow, and make it not move. So I'm liquefying the solder that is already there, and voila, I catch the wire there. Voila, you see, I managed to catch the wire. And that's one very fragile location. And now I am putting it on 45 degrees, like that, you know, like that, over this gap here. And what I'm doing exactly, I am bending the wire a little bit like a corner, you see, and I'm dragging the wire from this side here, hinged here in this resistor. And now I prepared each resistor with a little bit of solder on their tips there. So there is something to catch on, but it's not much. That's the problem, you know, it's not much. And it doesn't need to be that much. And that's it. And now I'm testing it. I'm testing the wire by dragging it this side. I'm dragging it opposite. And I have my little tweezer, not tweezer, thingy. And I want to cut it as close as possible from there. And now I'm bending because it leaves a little tail, very little. And that little tail is having the opportunity to make a short. And I really don't want that. And I'm melting the solder a little bit there in the bottom with that little tail turn around. And that's it. This is the wire here. Can you see it? I can barely see it. You will have exactly where I'm pointing with my knife. It's the diagonal like this wire, you see? And yeah, that's a very finesse, very fragile wiring what I'm doing there. And this cover is good, is more than good. Trust me, it is very good. And this is how I'm doing the wiring. I hope you like it. And after I will finish wiring everything, I will test it and I will update you later. All right, I hope you like it. All right. Oh, testing time right now. And actually you need, come on. Actually you need to see everything that I have here on the display. And there it is. This is the proper order. Actually, you test it like this and move the jumper around. But I will do it unconventionally, pretty much, just for testing right now. So here is 90, 89.7, it means 90. This is 79, which is 80, 70, 60, 50 kilo ohms. This is 40 kilo ohms, 30 kilo ohms, 20 kilo ohms, and lastly 10 kilo ohms. And this is 0. And yeah, it's working absolutely beautifully. And after I will seal it with the protection board. The only option to measure it will be only by moving the jumper around. To show you, this guy here right now is on 0, and if I'm moving it, let's say to something there, 4, it should be 4 kilo. This is 1 kilo, and this is 10 kilo. And this from here to here, 3.8, 4 kilo. You see? And if I'm moving it to, let's say, to 5, it should be 4.9 or something, which I really hate. This is 5. I hate it because it's a little bit less. You see, 4.8, which is 5 kilo. And that's how it's working. Pretty cool design. I really like the design. Even if it's not my design, I still respect it. It's a very good design. I really like it. And that's why I decided to continue it, to add this 10 kilo and probably hundreds of ohms. 1 kilo and 10 kilo, and probably hundreds of kilo ohms. So I will see. Most probably hundreds of ohms. 1 kilo, 10 kilo, and pretty much I'm on, you know, I hope I can make all 7 of them. But for now I have only 2, and I'm thinking to make the 3rd one, and most probably the last one, because it's quite hard to make. It's not that much to make, but it needs precision, a little bit more precision that I'm used to. Not that I'm not building with precision what I'm doing usually, but this is extra precision. You have to be extra careful than I usually I am, you know, and it's a bit hard. It's a bit my muscles on my back are a bit singing, you know. But yeah, I finished this yesterday, and today this one per day pretty much. But I will see if I can push it today to make the 2nd one for today, or the 3rd one in the line. Also, I will have to add this long cardboard here, put the protection, and make it exactly like the other one, and also put the labels, because now they are starting to be more than one. Yeah, this is way better aligned than this one, and I start to get the hang of it. But it's the same procedure. I'm cutting 2 from here, bend them from this side here. I'm not even lowering this. I'm bending it like this, left and right, after it's cut, and then I'm preparing them there. I solder them on the pads, and after I'm soldering all of them, I'm lowering this little plastic guard. I'm lowering for all of them at once, and that's it. They are practically remaining as they are originally, like this, bending stuff, soldering, and then I'm lowering a little bit down, and that's it. It's the lazy way and the efficient way, and yeah, you get experience with practice, I guess. Come on, Buster. This is my test. It's a 0 resistor. It's marked as 0. I will not cry if I will lose that. I have absolutely no use for 0 resistors, but I grab them from scraps, and I still keep them. All right, that's it for this update. I hope you like it. Hello from Romania, from your favorite artist electronics here, Mr. Q12. I got into the crazy mode, and I made this for 100 times 100 ohms times 1 kilo times 10 kilo times 100 kilo. They are, for the moment, they are separated, but they will be linked together exactly in my very short diagram that I have here. But I have, the discussion is not about those, but I will come to them. I have two options. I discovered two options. Well, the first option was with the jumpers that I'm having there, but the second option is with this rotary, I don't know how they are called exactly, switches, probably rotary switches. And basically when you press the button, it's changing. You see the number there, and I can tell you, I made some mistakes. I made some stupid mistakes, actually. I couldn't figure it out. I couldn't think how the fuck should I link all of this. So it took me like 2 or 3 mistakes to make, and think very, very hard how to transpose what I'm having here to a rotary switch. It wasn't easy. It wasn't intuitive at all. And originally, when I was probing, I was getting the inverse. When I was getting on 1, so when I was getting here on 1, when I was measuring, I got 400. I put only these four resistors here, and when I measured them, I was getting on 1. I was getting 400 ohms. By the way, this is times 100 ohms. Is exactly like this one here. So this is what I used, the resistors that I used. As you can see, they are SMD resistors, 101, 100 ohms each. And I really had to think very, very hard. And I really couldn't understand how to make it, as embarrassing as it is. Here I made a drawing how it should be everything linked, and how it's looking here, how I should, because I was looking through this, looking here, and getting the numbers, looking beneath it. But in reality, I am working like this, and I had to put it there, and I still didn't get it, even if with the drawing itself. And the solution was a bit non-intuitive. I had to track. To figure out the logic, how to actually get it right here, corresponding to the number, and the correct links, the wiring that I'm having there. And you start you start to do it in your head how it should be. And I get it 2 times wrong. I linked and I soldered everything wrong, and I desoldered everything. I clean it up. I take it down. I put this. I was thinking this common line. It will be this line common, and I link it to the common line that is there. Let me take one, and as you can see, is a C there. C from common. You see that in the middle. C is 0. This is a 9. C and 0, and that C, it means common. And you see, it's very, very good contrast right now. And I was thinking to link this common line to that common pin, and it didn't work at all. I was getting 100 ohms per each iteration. What the fuck? And then I said to myself, I should put a few of them, not all of them, and try to figure out the logic. And I did figure it out in the end. And pretty much what I was probing the common, and the last one that I'm having there. And that's why I was getting the inverse. When I was on 1, I was getting 400 ohms. When I was iterating, moving up 2, I was getting 300 ohms. Here I was getting 200, and here I was having 100 ohms. And because and then it crossed my mind, it should be something inverse. And I was thinking maybe this junction wires, very, very thin wire that I'm having there, maybe those, but it is having absolutely no sense if I'm switching their position. And I didn't switch their position because it really doesn't have any sense. So the inverse I should have do it was to to imagine how the current is flowing through the resistor, is going to that path, is going inside here, is making the switch exactly like that jumper, like one of those jumpers, is making the switch there, the jumping, and then it's coming out through here, through this common wire, the middle one that I showed you. You see that one, the middle one. And unfortunately, everything is destroyed here because I did put like 2 or 3 times. I saw that everything is very, very messy, and I covered those letters, those numbers. Yeah, I don't like it as how it's looking right now. It's very messy, but I did try the shit out of it until I hammered it until I figured it out. And yeah, it wasn't very intuitive from the first try, definitely not. And now I know better. This is the logic actually. Let me show you in parallel with this one where everything is showing. So one wire is on C. You can see actually the C letter there as well, even if it's full of solder. So one wire here, this one, and one wire. So it's 0. I didn't put anything on 0 here. I'm not sure. Yeah, you cannot see because the wire is staying on top of the 0 pad, but 0 pad is not linked to anything. So I started with 1. I put the resistor up, and I linked the wire on the top of that resistor, which is, you see, is on the top of it. And then the next wire is from the bottom of that resistor to the top of the next one. Bottom, top, bottom, and top here. And from here, I had to link it. As you can see, this numbering is a bit funky. So it's 0, 1, 2, 3, 4. You see, 4. And here it's starting 5, 6, 7, 8, 9. So I had to link from here, from the top of this resistor, no, from this pad, from this 4 pad to the top of this resistor that is on 5. So I had to drag a long wire, and it is a long wire. You will see it here underneath, and it's coming. You see it here on the margin. It's coming on top of this one, and it's continuing in the same. Let me actually zoom in a little bit, not much, because it's quite hard. Yeah, you see, bottom, and these resistors are floating on one side, and only they are catched only on one side, and definitely it needs some protection. I put this cardboard here because, let me zoom out, because I have those very, very thin tracks that I don't really need it, and it's very hard to catch the solder on them, and you can bridge them very quickly as well. So it's double trouble. And also these ones, I had some problems here on bridging them, and I had to clean them up with my knife, of course. And but I put the cardboard as a distancer. I make a distance. I'm pretty much covering those very thin tracks that are there, that I don't want to use them, because they are very thin and not really, centered. When I'm putting the resistor, I'm putting in line with this thicker track the pad itself. Let me actually point like this. So from here to here is the track, and from here to here is the pad, and this is another track, and this is a small or half of a track of a pad here. So pad and track, pad and track. Okay, this is the differences in my mind, at least, how I'm making sense of everything. And it's good to make differences because it will help your shit that you're doing. And this is it. This is the logic that I had to use it. And let me actually demonstrate it, because when I'm saying it with my words, it's good enough. So right now is on 0. Let me switch to 1. And I'll link it like this. I hope I did manage to hold it with one hand, actually. And I can't right now. And this is actually like this. No, I don't know how to hold it. I don't remember how I held it with one hand before, probably like this. But it's hard to show in the same time. So this is 1. I hope you can see. And this is 2. And look on the... And this is 3, 4, 5, 6, 7, 8, 9. And 0 is not connected to anything. And this is again 1. And it's 100 ohms. Because it's a small tolerance. So yeah, I managed to hold it with one hand. So it's fucking working. But the bad side, of this construction is that it took me only this module. Well, I had to experiment quite a few hours. I had to experiment, but only this module took me like probably 6 hours in one day today to make it. Also, I had those mistakes that I made, and the next ones, all of them probably, I will make them way more quicker, probably in 1 hour or even faster, probably. But I am, I am very, very, the energy. I don't have any constructive energy in me anymore because of all of these failures I had to get over, and I didn't stay and think from the very beginning. I jumped directly to soldering, and I was very sure it will work from the first try, and it's shit in my head. I was thinking I will escape with this module without making those diagonal transition linkage that I'm having there, and I didn't. Shit. But this proves a point. This proves the point that every circuit like this will use this circuit. This diagram pretty much is general. Doesn't matter what you are using. If you are using a module like this, semi-automatic, this is called semi-automatic, or manual, jumping manually. And I find this. That's why I stopped here on this 4. I think is enough, and it was a ton of work. My mind couldn't think anymore clearly after all this work. It was way too much as I originally thought it would be. I thought it would be simple. By looking on the circuit diagram itself, you say, it's not a big deal. It's repetitive. Yeah, you can do it. Yes, it is easy. It is easy to make it, but making it manually like I did it on cardboard, bending everything, and making some steps to follow and even if I'm doing it like this, I'm not completely sure these are durable enough. So most probably I will switch to this, or I will build them both. I will take a break from this, and I will continue to add more values to these guys, to continue adding them up like this. And as you can see, they can be stuck together, which is very, very convenient, and they are quite small. Comparative with this is quite kind of the same. Probably this is a bit higher. Yeah, it's definitely higher. Yeah, it's higher. But you see, it's a bit more compact, but the difference is really not that big. But I like the semi-automatic feeling of it when you press like zack. It's pretty cool. It's pretty cool idea. And I thought of it with me alone. I discovered I had these modules, and I said to myself I should try it on one of these as well. But yesterday I searched specifically if I can find a configuration like this, and it is a resistive box. This is called a resistance box, or it's having multiple names, unfortunately. But the usual one is the resistor box. And actually, these are actually having another name. The resistor box is having a spinning wheel, or buttons. But this is called, the fuck if I remember. I don't remember right now. But they have a slight different name. But it is in the same ballpark. It's in the same category of switches, multiple. And I like them very much because I get every value, for 100s, for 1 kilos, for all the 10 kilos and etc. And you can make combinations. And this is promising to get the same result as those. And being semi-automatic, it will be very interesting. And I will have to make a case, probably from metal, to encase everything, to protect these very flimsy and very fragile boards. I treat them as cardboards, as my cardboards that I'm making. And I'm very careful with them, not to press them, and also to protect them quite seriously. In the very end, not right now. But in the very end, when I will have everything, it will be very interesting to switch from this to a certain value, it will be very interesting. And very interesting how I will actually, the direction, which one will be ohms, kilo, tens of kilo, 100 kilo, mega ohms, from left to right or from right to left. like here I have 100, 1 kilo, 10 kilo, 100 kilo. So this is from right to left. I'm not completely sure how to make it in which direction. I like the modularity of this. You can switch them very quickly from left to right or from right to left. You can switch them, like that or like that, which is very good. Exactly like I'm having it. These guys here. But mines will be harder to switch around because they will most probably they will be glued from a cardboard, and that's it. When I will glue them from the cardboard, I will have to deglue from them to switch the order if I'm changing my mind. But these guys are quite more interesting build. You can switch them from right to left and left to right a bit more quickly. I'm not sure. Once I will add a common wire, probably it will not be that quickly. I'm not sure. But for now, it's quite interesting. I will have to, in the end, I will have to decide in which direction. But really, it's not really a big deal, the direction of it. The big deal is that it is quite hard to do it, and I did it, as you can see, at 90 degrees. This is soldering at 90 degrees like this. The resistor is staying like this vertically, and the pad is here, and the soldering had to be here in between this and this. And it was quite hard because the solder was catching here on the resistor pad, or not catching at all, on this pad here, on these 2 points, but not here, not here in the middle. So I was making like a bridge of solder pretty much, and that bridge of solder collapsed when it was liquid, and that's how I managed it. But quite hard to do it at 90 degrees. And that, remember, the leg of the resistor, the pad of the resistor is very close to the actual pad here, and it's I don't like this design, not really, but I managed to make it. Probably this is a stupid design what I'm having here, but I was thinking to save the numbers, to not attack them with solder in any way, and mount. This will be probably the next design, the next one in line, to put the resistors here. Of course, I will put a cardboard and the resistors on the cardboard, and the link will be between the resistors and the pads here on this end. And in this way, I will save these numbers to actually see them and not covering them like I did this fucking mess that I'm having there, and I hate it. I don't like it at all. I like to work quite cleanly usually, but if I don't know what I'm doing, especially in the prototyping stage like I did here, well, shit gets ugly. And so my next approach will be, I will have to keep in mind how to make it a bit more cleanly the next time, and I hope I will get a bit more interesting result from building it like this horizontally and not vertically like an idiot like I did there. I hope it will work. I wanted to show you the development that I got until here, this 4 until now, and this guy that is actually working. I managed to work and in the correct direction. One is 100 ohms and actually succeeding in order and making the correct value, 300 ohms here in this case and so on. And yeah, I don't like I'm having 2 projects for the same thing. I really don't like it, but it's an interesting development. It's good to have variation. It's very good to have variation, and that's what I'm counting for. 1. And I suppose, see you later after I will finish this entire fucking madness project, because this is a madness project that I'm having here. I thought in the beginning, yes, it'll be easy, and it is in some way. It is easy in some way, but manufacturing it, making it with your hands, it is hell. It is hell. One other detail. I made the first one was this 1 kilo. It was in 1 day because I had to prototype it. I had to think of it, how to make it. Then the next day I made these 2 guys, 100 ohms and 10 kilos. And in 1 single day I managed to make it, and it was completely hard, crazy hard, like mental, like the English are saying. Are you mental? Yes, I am mental. And these were mental hard. They were no fucking way. And then the third day, after half of a day break, I watched some movies. I played a little bit of games to relax, And then I said to myself, let's build this the 4th one, in the idea that I will make the 5th one as well too in the same day, but I just couldn't. And this was the last one that I made from this little 4 in the series in only 1 day, and that was yesterday when I made this one. And the next day after that one is this, when I made this, and it took me 6 hours to make it, to figure it out, and it's working. I'm very happy that I make it work, but it is mental and madness to make such a project. It's but it is interesting. I still find it interesting, and I think it's cool. I think it's very cool. I hope why I'm saying is madness, because a lot of stuff usually that you purchase and they are already made, you don't really use them. And even if I'm using my my skills with the cardboards and everything, my biggest disappointment will be if I will not use them at all. Neither of them. Build them and that's it. I will throw them away, and that will be a very big disappointment for me, because I did put a ton of work and hours and days and time, and it was, you have no idea. Try to make yourself only 1 module and you will see how hard it will be. Very, very hard. Very hard. My patience is so much, after that I know. And I'm kind of running out of patience with these guys. They are too repetitive, and the project itself is not really promising any continuity of if I will actually use this this entire object that I'm making here. I'm not sure. We will see in the future, and I will have to test them in time. Time will tell. But from what the feeling that I'm getting is that I will put them aside and forget about it. I hope not, but yeah. Thank you very much until here, and I hope you like it so far. And as disastrous as a project as it is, in the final, in the very end, when I will not use it at all, I hope not. I hope I'm mistaken. But yeah, thank you very much for watching. I hope you like it, and also leave a like, motherfucker. Don't be a motherfucker. Leave a like. And we will see you next time. Bye bye. From your favorite artist electronist, Mr. Q12. All right. Hello to your favorite artist electronist here, Mr. Q12. All right. So thank you very much. So I made here the 100 ohms model with everything on vertical, with the resistors on vertical, and the pads are horizontal, pretty much 90 degrees, and it's weird and funny. I don't like it. And here is the second take, but is next in line. Pretty much is not 100 ohms. This is 1 kilo. Every resistor here is 1 kilo. Let me zoom in. So this movie is about this body that I made here, and actually, let me point it with my needle. Do you see these fine wires here? They are crossing from one side to the other, and here on this side you can see a little bit of wire there, and it's coming from here like this. It's bent like this. I actually have some holes. So let me take it. You see, I actually have these holes, but the resistor is quite over this hole, and when I push the wire to the hole, it was pushing the resistor up, and that one from the 4 line or pad. Actually, I can keep them like this. What I built there, I put a piece of cardboard. It's very thin cardboard. Actually, let me zoom out. Here, I cut different sizes of the straps. This is very thin. This is very wide. And what I use there is half of this, pretty much half of that. And yeah, I believe it was half of it, probably a little bit, no, half. And I glue it. I used uhu. This is uhu stick, baton de cola. What the fuck? Limstift, lima puikogo, lepich, whatever. It means it's not saying in English, huh? Very weird. But it's saying in Romanian here. Crayon de lipit. It means sticking crayon. Crayon for sticking. Yeah, it's a shitty name. Doesn't matter. But I use that one instead of that one. They are quite the same. And so that side is not very good for sticking. And having this side up, I'm assuring that there's no connection, no mistake for any kind of connections. And yeah, pretty much. This is it about what I have there. That cardboard is lifting up and keeping all of the resistor at an angle, a very slight angle, not perfectly horizontal, because they are staying on the same pad. So as you can see, I can show you a new one here. So the resistor is staying pretty much on the same pad, and if it's horizontal, it will short itself. It will not conduct. It will not do anything because it's the same track there. But by inserting that cardboard, I am isolating the other connector of the resistor. The other side, the connector, of the resistor. I can do the circuit this way, by inserting that little strap of isolation, the cardboard, and pretty much, these are the points. I drag the wire. Let me zoom in a little bit. So I've dragged the wire from the 0. You see, this is a C letter. This is the number 0. And I drag the wire to here, and these are the 2 points where I'm taking the value, the resistance value. And these are the 2 points that I will connect in my circuits in the future. And as you can see, that's why I build it this way, all horizontally like this, to protect these numbers that I'm having there, and not like this crap that I'm having here. That is, I kind of destroyed those letters, but it's still good enough. It's still working as it should be, even if it's but we learn from mistakes, right? And I make mistakes, but the difference from a rookie and a extraordinarily professional electronist like myself is you don't quit, even if you are making mistakes. Doesn't matter. It really doesn't matter. This is a philosophy. This is a mentality, and you have to get over your mistakes and continue and push it further and correct yourself. This is the difference from a professional working guy. If you are able to correct yourself, even if you are making mistakes, you are a professional. If you are a rookie, you will put your nose in your butt and you will walk away and leave the project behind, and get upset and get emotional and get start to swearing and uncontrollably. I know, because I was young myself as well, and I did mistakes, and I leave the projects unfinished for a very long time, and I am sorry now that I could have pushed them a bit further, and I didn't. And this is a history, and everybody is making mistakes. There's no question about it. The big question is if you are willing to continue it and push it further. So this is more professional right now because I push it further, even if I'm having that shit there. I'm not bragging with it, but I'm telling a story with it. And yeah, so pretty much I'm saving these numbers and markings that I'm having there. I'm protecting them, and in the same time I'm getting the same functionality as I had there, and it's a bit more. It's better. I believe it's better. And let me test it for you to actually see how it's working and how is everything is running. Because no, it is okay. I don't know how I will keep it in my hands. So, will this be good enough? Let's see. Yeah, it is good enough. Like that. All right. I don't know how I will keep it in my. Right now it's on 0. Let me find. When I was doing it like this. It was quite easy to hold it like this. But if I'm having to do it vertically like this, it'll be a bit shitty. So I hope I will make it. Wait, one hand here. One. So there is 0.98. It means 1 kilo. It's set to 20 kilo there. And okay, this is 2, 3. Let me. Yeah, you see, 3, 4, 5 kilo ohms, 6 kilo ohms, 7 kilo ohms, 8 kilo ohms, 9 kilo ohms, and 0 is getting back to 0. And is these 2 pads here, and very, very elegant. I want to say it's way more elegant than this shit. And yes, I make mistakes. And I'm very happy that I finished it. And also I'm keeping the modularity between them, intact. I can insert them one next to the other, and also not making any kind of short circuits, which is good. And but that goes without saying. And I wanted to show you the construction of what I built here. And this is it. Thank you very much. I hope you like it. Also leave a like. And yeah, thank you very much. All right. Oh, this took me quite some fast time to build it. 1 hour and a half, I believe. Probably 2 hours. 1 hour, 1 hour and a half. Maybe 2 hours. I don't know. I really don't know. But it's quite fast because yeah, I knew exactly what I have to do, and I replicated. I looked at this one that I kill it to death there, and yeah, quite fast time building it. And I believe if I'm putting my mind to it, I can build all of them in one single day. But we will see that in the future if I will be able to. But so far so good. The time is absolutely incredible fast from usual building this stuff. All right. Here is an important update that I have. Actually, let me bring up the light. So I put all these modules. I glue them on this cardboard here. It's you know how I'm doing everything on cardboard, and I glue them with my shoes glue that I have here, extremely adherent, especially for smooth surfaces. I put the glue on all the surface, all this component module. I fill it all with glue and stamp it there, and actually move it like this a little bit, and then position it, and that's it. That's how I glue it. Next, I had to add, as per schematic that I have. Let me make some rooms here. And as per schematic, I have to link from here to here pretty much, and these are the links here. 1, 2, 3. Actually, I cut 4 of them. And yeah, this is a long blue wire, but I had 2 of them, and I sold it because I'm cheap and they are scrap. And this was bending extremely quickly because it's so long. Was bending in the wind like this. It was moving around. It is secured here. Is this wire here? You see this long wire here, and it is secured there in the end. But in this other end, it was flapping in the wind. And how to secure it? I'm using sewing thread. And I saw it pretty much. You can see here, and here is sewed on this other part as well. And that's it. It's holding it quite elegantly. It's holding it there and not letting it flapping in the wind. Like I said, I had this. This I made it myself. I took 2 pins like this. You see, I cut them and I put some. My favorite thing is looking like a turd, like a shit. But despite it's very good. Actually, I built this a long time ago, not right now. I had it in my box of wires here, and I had it was short here for some reason, and I had to find its other piece, and I find it, and I link it there, and this is how it's done. I like this plastic that is transparent or semi-transparent at least, and I can see, and I actually see the wire color where they go, which is great, and it's functioning very good. I have a good grip here to catch it with the fingers, and I made it as for me. So this is the final construction for, at least for this stage, that I made 4 of them, and it just melted all my brains, all my neurons in my head. They melted as hard as it was. It was very, very hard to make it. I didn't expect it to be this hard, and I do it in 3 days. I probably said it already, but I repeat it. This one, I think the 1 kilo was, I made it in one day. 2 of them, this 100 ohms and 10 kilo in a second day. In the third day, I made 100 kilo, and I believe this one as well. And so the fourth day, meaning today today I made this one, the fourth day, the upgrade, and also today I made well, I don't like stuff that is unfinished, and I decided to, even if I built this one and I was pretty sure I was going to make all of them. I have the others in another place. I have to take them out and to make all the 7 from one home. And but I put a pause on them because I know exactly what I will get from them, and I was curious how this will behave as a component or device, probably it's called. And I find a very serious flaw in the design itself. I mean, the design is very good. I really like the design, the wiring, the idea of it, having all the values. It's having a lot of good points, a lot of them, and I really like it. That's why I jumped into it to make it as you see it. But it still, after you actually put it to work, you still have a very, very serious problem, and probably that's why people are not really raise it that high as a good component. I'm not sure really, but for sure I'm not. I mean, I have to remember this little problem that it's having. So what I'm having here, I'm having the 5 volts there, the 2 sticks that I prepared for the phone here. These sticks are very important. So I put, as you can see, red is positive to here, and black is negative to there, and it's linked here. And I have positive going through this pin, going through all this stuff, coming through this pin here, and going through that positive leg that is bent of the LED, negative leg of the LED, and going to the negative rail here. So, and this as well, positive and negative, okay? I prepared 2 of them, 2 models. And let me put my phone here on its place. And the problem, let me close the lights to have a bit of better contrast. If I am connecting this jumper directly here on the top, it'll put 5 volts directly on this poor LED. Fortunately, my this LED is supporting that 5 volts, and I actually made the test. And I will do it very quickly because you see it's extremely bright, and it will burn the shit out of it. So if you forget everything on the first line here and you plug it in your test that you want to do, if you forget this little detail, you will burn the shit out of whatever you have there. And if you think it's still correct, check this out. If I'm putting my fingers even here, yeah, it's pretty cool. And here, no, it shouldn't here. So it should be like this. So now let me actually put it on 100 kilo. So I will switch to 100. It's let me show you up close. So this the first one is 0, and the next one is 1, very close to the 0. And this is probably another problem. Because they are so close together, you think it will be okay, but if you make a mistake and you put it on 0, now the LED will shoot itself. And if I'm putting this on 0, 0, 0, 0, and this is on 100 kilo here, if I'm pressing for some reason it's interrupting, it shouldn't. Yeah, it's good. So now is at 100 kilo, is lighting up through 100 kilo. Everything I've already made the test, and I had some little detail, a little problem there with 100 ohms. I hope it will not get back that problem. Let's see, on 500, probably it's here. Yeah, it's even dimmer. And all 900 kilo, it's 1 mega. I didn't put it right. This is 1 mega. It's still lighting. Motherfucker is still lighting. It's absolutely incredible. Very exceptional LEDs. These are new. With 900 kilo on it, almost 1 mega. It's still lighting, motherfucker. And it's not a motherfucker. It's very good. Now I just forget. I was almost on the point to plug it in onto 0 there. I will have to take it out and use only 3 of them to remember which one I want it on 0. Probably. No, it's not working like that. I still have to, yeah, it's very interesting. You see, if I'm touching, it's very interesting. It shouldn't here because it's direct connection there, but here it is. Very cool. I have a little bit of resistance in my fingers, so this is 10 kilo here, but let's go to 90 kilo. It's almost 100 kilo. Let's go to somewhere in the middle, 50 kilo here, and this is 10 kilos. This is optimal, at least for me. It's not too bright, it's not too dim. It's absolutely good. It's not violating my eyes. The brightness is not that bright that is fucking with my vision, so that's 110 kilo there, very close to 0, which is a dead short, which is very not good. I don't like this little detail. I don't like it with the 0 there for some reason. I should probably put it here on the I don't know. And right now I'm taking that one out. I'm putting this 0 here in. I must be very careful with this arrangement. So now I'm putting it at so I'm putting it on 9 kilo, which is almost like 10 kilo like before. 5 kilo here is a bit more brighter than before, and this is 1 kilo here. This is 1 kilo. It's very bright. This is it's starting to fuck my eyes. So now I'm taking it out. I'm taking this out. I'm putting it on the 0. So all these are shorted. And now this is 900 ohms. It's almost like 1 kilo, almost. And here is 500 ohms. Very bright. And this is for a very short 100 ohms. But it's blinding. It's like welding, blinding. So I will take this out here because this is interesting. This is all the thing. Let me reset it back to 10 kilo. So these are all in reset mode in connection, and I will put it on 90 kilo, nothing happens there. I put it in 50 kilo, nope, nothing happens. On 10 kilo, opa, it's starting. Let's see again, 50 kilo, really? It's very, very, extremely dim. I'm not sure if the camera is actually catching something, but it is at 50. You see it? Not, you see, at 50 kilo, barely. So this is 10 kilo here. It's kind of lighting up, it's starting to lighting up. Okay, I will take this one and put it here. And we will test with 1 kilo. So 9 kilo right now. It's almost like 10 kilo that we see before. Definitely, this is way more shitty technology that they used in them comparative with the super bright that I have here. So I tested on 9 kilo. Here is 5 kilo. 5 kilo. And this is 1 kilo. Opa, is starting to be interesting at 1 kilo. But it's still not bright enough. It's still not bright enough. I don't like its brightness with 1 kilo. So we have to use actually the 100 ohms. And that's why I made this 100 ohms here, because I knew I'm having some LEDs that are working somewhere 400, 300, sometimes 200 even ohms. They need like some LEDs. It's, yeah, I will take this out from here. I will put it here on the 1 kilo. So like that. And I'll put this on 900 here. 900 ohms, almost like 1 kilo that I had there. 500 ohms. And so this was, you see, 900, this is 500. And 100 is pretty bright. This is quite good. But usually I don't want to stress it because it's questionable. Probably it will break. It's very questionable. And I will put it on 300. Yeah, it's good enough. You see, it's very close to 100 there. 100 and 300. Yeah, 300, 200. Yeah, 300. So 300 is the luminosity is good enough. On the the most important thing that I really like about from the very start when I started this project, usually how I'm doing things, I'm using those boxes. You see those boxes, they are full of resistors, through hole with legs, and like these ones, okay, for every values. This is 1 kilo, for example, and it's a through hole one, you see, and they are full of them, and also brand new and scrapped, both of them. Let me, yeah, like that. So both of them are both categories, new and scrapped, and really, usually, this is exactly how I'm doing it. I'm going there, I'm taking one big tray of resistors. I'm searching for the one I need. I'm taking the matchbox that I'm having, the particular matchbox, and taking it out. I'm pushing out the drawer, you know, like this. I'm pushing out the drawer. I'm choosing one resistor from there that is new, because when I'm doing the testings on the breadboard here, I'm choosing the value. It's a bit of pain in the butt, especially rising up and putting my ass down on the chair is not that pleasant. And this is solving exactly that problem that I'm having on going there, taking out, moving all this shit, and then putting it back. And this is resolving all that problem. Very, very efficient from this point of view. Very efficient. And the only thing that I have to remember is not to make the short, because it's deadly for some components, not for all, but for some components it's deadly if I'm putting it pretty much 5 volts directly on the positive and the link to negative, it will burn the shit out of it. And we definitely don't want that, because I have too many burned LEDs in my past, and really it's not that I learned my lesson. I super learned my lesson, and I really don't want that. And you don't want that as well. It's not fun, and it's really a waste of components if you are burning them like an idiot, like I did, and in the past. Not that many, but I was sick of it. I was trying my best not to do it, and finally, something in my mind switched, and I started to get it right. And it's correct for every other components, not only LEDs. With LEDs, I learned the hard way, if you want, but it applies to other components as well, to transistors, to whatever you are programming. You have to get a method of doing things, you know, a mentality. And after you learn that mentality, you will do it for everything. For chips, especially for chips, for ICs that are very expensive, and you have to take care. But there is another problem with chips. There are other problems. But this is still applying when you are playing with multiple values to test the things, and it's very, very, very good. I want to believe that this will be better than what I have here. I want to believe that. I want to believe it will be better. I'm very happy that I built this small module, component, whatever it is, and I tested it, and it's totally working as expected. And I did find some flaws. The major flaw that is having is all of these guys on 0 here. It's very, very not good at all. I will have to either think of a solution by myself, and I doubt I will find one, or I really don't know. We'll see. Okay, thank you very much for watching, and I hope you like it, and also leave a like, and see you later from your favorite artist electronist, Mr. Q12. Here, the best of the best. All right. Goodbye, and see you later.